There were several questions over lesson 6.1, which was on sine, cosine, and tangent. I'm going to start with question number 6. Number 6 said refer back to one of the questions in the textbook. I'm going to go ahead and recopy that picture down. They gave us an angle of elevation of 50 degrees. We were looking for this height, and we had this length right here to be 30. So first thing I need to recognize is I have the information on opposite over adjacent, so that means I'm going to use tangent. So we have tangent of 50 degrees equals x over 30. I'm going to cross multiply, and I get 30 times tangent of 50 degrees. When using your graphing calculator, you have to make sure that you are in degree mode. When I solved this on my calculator, I got 35.726 feet. What you have to notice back in that picture, though, they show you that you actually have a man or an individual standing here, and their height is 5 feet 3 inches. So first thing I'm going to do is I've got 5 and 3 inches, which would be 5 and 3/12 of a foot, which is equivalent to 5 and 1/4, which eventually gives me 5.25. So this distance here is 35.726, and then I have to add on the 5.25. When I do that, I come up with 40.97, so I think they say that's approximately 40 feet. Next question was 7b. It said find the exact values, explain why these values are equal. So let me again just draw out that picture. We have this is side is 3, this is 4, we have to go and find 5. And I'll label the sides. And the first case it's asking for the sine of d, which is equal to opposite, which is 3 over 5. The second one is the cosine of b, which is the adjacent over hypotenuse, which is 3 over 5. This actually relates back to the last unit. This guy was theta. This one was 90 degrees minus theta. This was called that complements theorem, which will always state that the sine and cosine of complements are always going to be the same length. Number 9. Number 9, again, I was given a picture. I'm just going to redraw that picture out. I have an angle of 65 degrees. This is 11 1/4, which is 11.25. I'm just going to recognize again, with respect to this angle, I have opposite over adjacent, which is tangent. So tangent of 65 degrees, x over 11.25. Again, I'm going to cross multiply. We get x equals 11.25 times tangent of 65 degrees. When I plug that in my calculator, I get 24.125. And I think they wrote their answer as a fraction. 0.125 would be 125 over 1,000, which eventually reduces to 1/8. So we get 24 1/8 feet. Okay, moving on to the next question, if I can squeeze it on here, is 10b. Find the coordinates of point E. So let me draw that picture out. I have E, F, and D. I've been given the hypotenuse is 10, and I know this angle is 127. So the first thing I'm going to do is go and find this angle here. 180 minus 127 is going to give me 53 degrees. And I'm looking for my coordinates. So technically this is my x coordinate and this is my y coordinate. So I'm going to actually set up two trig equations to find each of those. So With respect to looking for x, that's adjacent over hypotenuse. So I have cosine of, 53 degrees equals x over 10. Plug that in your calculator. And you end up with approximately 6. But keep in mind, because I'm going left, my answer is going to be a negative 6. Now I'm going to go set up an equation involving sine. Sine of 53 degrees equals x over 10. We label this to be y. So y equals 10 sine of 53 degrees. When I plug that in, I get 8. And it truly is positive because I'm above the x-axis. And actually, the exact same thing is going to be true for number 11. The same setup we have for number 10, we have for number 11. So I'm just going to write a note that says, C setup